IEC 61131-3 is the international standard that establishes the rules of PLC programming. In this video series we are going to cover all the aspects that this standard defines. If you master these concepts, you will be able to program PLCs effectively, no matter what brand you are using. To truly appreciate the significance of this standard, it is necessary to understand the context from which it emerged. Each prominent PLC manufacturer developed its own proprietary hardware platform and, more importantly, their own unique programming software. This included custom languages and data representations that did not work with anyone else. This led to many challenges for PLC users. First, vendor lock-in. After specializing in one system, switching brands was incredibly difficult. It required a substantial reinvestment in hardware, software, and mainly training. Second, difficulty in integration. Integrating these different systems into one factory was exceptionally difficult. And finally, no code reuse. The absence of a common programming framework made it impossible to reuse code, solutions, or best practices among different brands. This is when the IEC, the International Electrotechnical Committee, stepped in to bring order to this chaos. In the early 90s, they released the IEC 61131-3 standard. This document established a set of core elements for all PLC manufacturers to follow. While the standard covers many details, for us as programmers it can be divided into three core elements. Number 1. It defined a formal software models for organizing PLC application code. It defined the three types of program organization units, also known as POUs, in which a programmer is supposed to write their own code. These units are known as programs, function blocks, and functions. We will dedicate a full video to the differences between these, but just know that the standard dictates how we structure our logic. Number 2. It defined the data model for the precise declaration of variables. The standard defined two key distinct aspects that must be specified for every variable. The scope, or visibility, this means where the variable is declared and how it can be used. Is it a local to one block or global for the whole machine? Is it an input or an output of a specific unit? The data type. This defines what kind of data is represented, like being a simple boolean, an integer number, or a real floating point value. Number 3. It defined a set of programming languages to be used when programming PLCs and creating POUs. The standard today features 4 languages. Ladder diagram, a graphical language that resembles relay wiring schemes, very popular in the US. Structured text, a very powerful high-level textual language with its roots in Ada, Pascal, and C. Function block diagram, a graphical language that is expressed through the interconnection of graphical blocks. Sequential function chart, a graphical language that resembles state machines diagrams. By standardizing these three areas, software models, data, and languages, the IEC gave us a universal toolkit. In the next videos, we will explore these three aspects of the standard in detail and create the foundations for building PLC applications. If you want to dive deeper into the history and details of the standard, check out my book PLC Programming for Beginners on Amazon.